According to the National Electrical Code, disconnects for heating, ventilation, and air conditioning applications should be fused unless specific conditions are met. These conditions are firstly, the short circuit current available at the location does not exceed 10,000 amps, and secondly, the equipment is rated for the available short circuit current. Determining the short circuit withstand rating of heating, ventilation, and air conditioning equipment is important. The short circuit withstand rating of heating, ventilation, and air conditioning equipment is not typically provided by manufacturers. However, it can be estimated using the following formula: withstand current equals rated current divided by the quantity of 1.3 multiplied by 0.75. For example, a 100 amp heating, ventilation, and air conditioning unit would have an estimated short circuit withstand rating of withstand current equals 100 divided by the quantity of 1.3 multiplied by 0.75 equals 92.6 kiloamps. In practice, the short circuit current available at a service can vary significantly depending on the location and power distribution system. It is common to see available short circuit currents exceeding 10,000 amps, especially in commercial and industrial settings. Therefore, it is generally recommended to use fuse disconnects for heating, ventilation, and air conditioning applications to protect against potential short circuit faults. There are additional considerations to keep in mind: firstly, fuse type, secondly, fuse size, thirdly, current limiting fuses, and fourthly, fuse coordination. Time delay fuses are typically used for heating, ventilation, and air conditioning applications as they allow for harmless overloads during motor starting. Fuses should be sized to protect the equipment from overloads and short circuits. They should be rated for the maximum fault current the equipment can withstand. Current limiting fuses can be used to provide additional protection against high short circuit currents. Fuses should be coordinated with other upstream protective devices to ensure selective operation. Based on current industry practices and the availability of significant short circuit currents, it is recommended to fuse disconnects for heating, ventilation, and air conditioning applications to enhance safety and protect equipment. When evaluating the need for fuse versus non-fuse disconnects, considering the potential short circuit current is critical. Fuse disconnects offer a higher level of protection where available short circuit currents exceed the equipment's withstand rating. Always refer to the National Electrical Code and consult with qualified professionals for specific applications and installations. Proper selection of fuses ensures safety and reliable operation of heating, ventilation, and air conditioning systems. Understanding fuse characteristics such as time delay and current limiting capabilities is essential for effective protection. Implementing proper fuse coordination minimizes unnecessary tripping and ensures continuity of service. Regular inspection and maintenance of disconnects and fuses are necessary to maintain their effectiveness. In summary, specifying fuse disconnects for heating, ventilation, and air conditioning applications is a prudent approach to mitigating potential risks associated with short-circuit faults, especially in environments where high available fault currents are prevalent. Remember to consider the specific requirements and conditions of each installation to make informed decisions. The information presented is intended for educational purposes and should not be considered a substitute for professional engineering advice. Always comply with all applicable codes and regulations when designing and installing electrical systems. Ensure that all electrical work is performed by qualified and licensed electricians. Pay close attention to the equipment's nameplate ratings and manufacturer's instructions. Conduct thorough short circuit studies to accurately determine the available fault currents. Select fuses that are appropriately sized and rated for the specific application. Implement a robust maintenance program to ensure the continued reliability of protective devices. Consider the potential impact of voltage fluctuations on fuse performance. Utilize current limiting fuses in applications where extremely high fault currents are anticipated. Coordinate fuse selections with upstream protective devices to achieve optimal system protection. Always verify the interrupting rating of fuses to ensure they can safely clear fault currents. When replacing fuses, use the same type and rating as the original fuse. Document all fuse selections and settings for future reference. Provide clear and concise labeling for all disconnects and fuses. Educate personnel on the proper operation and maintenance of heating, ventilation, and air conditioning systems and their associated electrical components. Stay informed about the latest industry standards and best practices related to electrical safety. By adhering to these guidelines and recommendations, you can enhance the safety and reliability of heating, ventilation, and air conditioning systems and minimize the risk of electrical hazards. The goal is to create a safer environment for both equipment and personnel. Fuse selection involves several critical factors, beginning with the available short-circuit current at the installation point. This value, often determined through a short-circuit study, dictates the minimum interrupting rating required for the fuse. The fuse's interrupting rating must always be greater than the available short-circuit current to ensure it can safely clear a fault. Next, consider the equipment's withstand rating. This specifies the maximum short-circuit current the equipment can safely handle without sustaining damage. The fuse's current limiting capability becomes crucial here. A current-limiting fuse can reduce the magnitude and duration of a fault current, protecting downstream equipment with a lower withstand rating. Time-delay fuses are often preferred for heating, ventilation, and air conditioning applications due to their ability to tolerate temporary overloads such as those experienced during motor starting. These fuses allow brief surges in current without tripping, preventing nuisance outages. However, they still provide overcurrent protection against sustained overloads and short circuits. Fuse sizing is another critical aspect. The fuse must be sized appropriately to protect both the conductors and the equipment it serves. Oversized fuses can leave conductors vulnerable to damage from overloads, while undersized fuses can cause unnecessary tripping. Consult the National Electrical Code and equipment manufacturers' recommendations for proper fuse sizing. Coordination between fuses is also important, especially in systems with multiple levels of protection. Selective coordination ensures that only the fuse closest to the fault opens, minimizing the impact in the rest of the system. This requires careful selection of fuse types and time current characteristics. Ambient temperature can also affect fuse performance. Fuses are typically rated for a specific ambient temperature, and their current carrying capacity may need to be adjusted for higher or lower temperatures. Consult the fuse manufacturer's data sheets for temperature dating factors. Proper fuse installation is essential for reliable operation. Ensure that fuses are securely mounted in their holders and that all connections are tight. Loose connections can cause overheating and premature fuse failure. Regular inspection and maintenance are crucial for maintaining the effectiveness of fuses. Check for signs of corrosion, damage, or overheating. Replace any fuses that are suspect or have reached their end of life. Detailed documentation of fuse selections, settings, and maintenance activities is vital for troubleshooting and future reference. Keep accurate records of fuse replacements, inspections, and any changes made to the system. Personnel training is also essential. Ensure that qualified personnel are trained in the proper selection, installation, and maintenance of fuses. This helps prevent errors and ensures that fuses are used correctly. Finally, stay up to date with the latest industry standards and best practices for fuse selection and application. The National Electrical Code and other relevant standards are constantly evolving, so it's important to stay informed. By considering these factors, you can ensure that fuses provide reliable and effective protection for heating, ventilation, and air conditioning systems, minimizing the risk of equipment damage, downtime, and electrical hazard. The type of disconnect also plays a role. An unfused disconnect simply provides a means to isolate equipment from the power source. It does not offer overcurrent protection. Therefore, it relies on upstream overcurrent protective devices, such as fuses or circuit breakers, to protect the equipment and conductors. A fuse disconnect, on the other hand, incorporates fuses within the disconnect enclosure. This provides a local means of overcurrent protection, offering an additional layer of protection for the equipment and conductors. Fuse disconnects are often preferred in applications where the available short-circuit current is high or where local overcurrent protection is desired. The choice between fused and non-fused disconnects also depends on the specific requirements of the installation. Some applications may require fuse disconnects for safety or code compliance reasons. Others may allow non-fuse disconnects provided that adequate overcurrent protection is provided upstream. Another consideration is the ease of maintenance. Fuse disconnects offer a convenient way to replace fuses without having to shut down the entire circuit. This can be particularly advantageous in critical applications where downtime must be minimized. In summary, the decision to use fused or non-fused disconnects for heating, ventilation, and air conditioning applications depends on a variety of factors, including the available short-circuit current, equipment withstand rating, local code requirements, and ease of maintenance. It's essential to carefully consider these factors and consult with qualified professionals to ensure that the disconnects provide adequate protection and meet the specific needs of the installation. The overall goal is to ensure safe and reliable operation of the heating, ventilation, and air conditioning system and to minimize the risk of electrical hazards.